Hello and welcome to assignment 2 code, the decision trees. Jumping right into it, we have our data type infos for all the different types of data. Jumping into the pipeline, we prep that data and we don't one-hot encode it or standardize it. Jumping into the cross-validation, we're doing our 5 cross 2 and using this as a jumping off point for the decision tree. We go into creating our decision tree. So for our classification tree, we begin by finding the best question. So we do that by jumping into this find best classification split. We iterate over every possible feature and generate a question, and we partition the data. And first, when we partition the data, we make sure that the true data length or the false data length is not 0 before we proceed. So once we do that, and once it's not 0, we go ahead and find the gain by finding the info gain, and we do that by finding the entropy of the true and false and taking a weighted average, and then subtracting that from the parent's entropy, and that's our info gain here. And our entropy, you calculate it right here using that log2, which is a helper function that we had to create. And so info gain, and so we set the gain of that question, and if that gain of that question is greater than the current max gain, then that becomes our best question, and that is our best split. So then here's our base case. If that question actually turns out to be null, then we've reached a leaf node, and we go ahead and create that leaf node. But if not, we use that question to partition the data into true and false. We create our new parent node, and then there's some inheritance stuff here that's used for the pruning. So we go, and then we create that partition data, and we create our true branch and our false branch using recursive calls. And then once those recursive calls are done, we then set our left and right branches to that for that new parent node and return that new parent node, which is a decision node. So the decision nodes are here, and then we create our leaf nodes up here using our base case. So that's our classification tree. And jumping into the regression tree, we do the same thing, but for the regression split, we iterate over every possible feature, just like we did for the classification split. We partition, same logic over here, but instead we're trying to minimize our error. So we calculate our error using the squared error. We calculate our averages here, and then we take the true data average and the false data average, and we try and find the squared error from that. And then if the squared error is less than the current min error, then that becomes our best question. And then so we find that, but if our length of our data is less than 20, then we have our leaf node. So if this data that is recursed on is, if there are less than 20 elements in there, we call that a leaf node because we need to call something there. So this is an adjustable value. So just so we did, we set our parent node, and we partition our data, and we create our true and false branches, and again, decision nodes. So looking into pruning the data, here's our base case. If the decision tree, this is a recursive function, much like the finding the classification and regression trees. So here's our base case. If the decision tree is null, or if we're in a leaf because there's no left and right children, or if the test data length is actually 0, if there's no test data that's plinkoed its way down to this node, then there's no point that we can't do any pruning. So we partition based off of the question at this point, because we've established we're not at a leaf node, we're in a decision node. We need the right and left data, and then we do our recursive calls, and then we have our proposed leaf node right here with the data at this decision node, which this decision node contains the data that it then partitions, and then we have our parent node so they can slot right in. And so looking at classification prune, we have a classification and regression prune. We take the amount of misclassifications from using the proposed leaf node versus the decision nodes, and then if the proposed leaf node has less misclassifications than our current decision node, then we make the switch. Same thing with the regression prune. If if the minimum error is less using the proposed leaf node than the current decision node, then we make that switch. So that is our pruning algorithm. And then so jumping back into the cross-validation, we do 5 cross 2 on the unpruned data, and then we prune it, and then we take the data, the results of that data, and then we print it, and then we take the best data point using that best pruned tree, and then we use that to iterate on. Then here's our decision tree. So this is our best pruned tree. And you can see it iterates out horizontally, and then here are our results. So thank you.